September 15th, 1916. The Somme Valley, France. Mud thick as concrete. A steel monster crawls forward at 2 miles per hour, smoke pouring from its exhaust ports. Inside, 4 men are screaming, not from fear, from trying to be heard over the engine roar. 1 man grips the steering wheel. 2 others wrestle with mechanical brakes on each track. The 4th operates a gearbox that requires the strength of a blacksmith just to shift from first to second. They're supposed to turn left. Instead, the machine lurches right, tracks grinding, and buries its nose in a shell crater. The crew stumbles out, gasping, uniforms soaked with sweat and oil. The Germans are 200 yards away, laughing. This is the Mark I tank, Britain's secret weapon, and it's a mechanical disaster. To understand why this moment represented the crisis point of armored warfare, we need to step back 2 years. By 1914, the Western Front had become a graveyard of barbed wire and machine gun nests. Infantry attacks achieved nothing but slaughter. The British Admiralty, specifically Winston Churchill and a naval officer named Ernest Swinton, imagined a solution: an armored vehicle that could cross trenches, crush wire, and shield men from bullets. The problem wasn't vision, it was engineering. How do you make a 28-ton steel box move, turn, and survive battlefield conditions while keeping the crew alive and functional? Enter Walter Gordon Wilson. Born in 1874, son of a Royal Navy officer, educated at King's College, Cambridge in mechanical sciences. Wilson wasn't a typical military engineer. He'd spent years designing automobiles and marine engines, obsessed with gears, transmissions, and the elegant transfer of power. In 1915, at age 41, he was recruited to the Admiralty's Land Ships Committee, the secret group developing what would become the tank. His partner was William Tritton, managing director of William Foster & Co., an agricultural machinery firm in Lincoln. Together they built Little Willie, then Big Willie, prototypes that proved armor and tracks could work. But Wilson saw what the generals celebrating those trials couldn't. These machines were undrivable. The Mark I required a commander to shout orders, 2 gearsmen to operate track brakes using long levers, 1 for each track, and a driver to steer and manage the primary gearbox. Turning right meant the right gearsman applying his brake while the left track continued driving. Coordination was nearly impossible. Engine noise reached 120 decibels. Heat inside the crew compartment exceeded 100 degrees Fahrenheit. Carbon monoxide seeped from the engine bay. Men passed out. During the Battle of Flers Porcelet, 49 tanks went into action. Only 18 made it to the German lines. The rest broke down, ditched in craters, or simply stopped when crews became too exhausted to operate them. Wilson watched the after-action reports pile up. He knew if tanks couldn't be controlled by 1 man, they would never be more than curiosities. The problem was planetary, literally. Wilson needed a gearbox that could do 3 things simultaneously: change speed ratios smoothly, allow steering by varying power to each track independently, and operate with minimal physical effort. Every existing transmission design, sliding gears, cone clutches, chain drives, required brute force or multiple operators. Wilson turned to something most engineers considered too delicate for military use: the epicyclic gear system, also called planetary gearing. Picture the solar system, a central sun gear surrounded by planet gears that orbit inside a ring gear. By locking or releasing different components using clutches and brakes, you could achieve multiple gear ratios in a compact concentric package. The beauty was mechanical advantage, small inputs producing massive outputs. One lever could do the work of 3 men. But here's where Wilson's genius separated from mere competence. He didn't just adapt epicyclic gears, he redesigned them for battlefield punishment. Standard epicyclic systems used in early automobiles were fragile, fine for paved roads, suicidal for mud, shell impacts, and 30-ton vehicles. Wilson specified hardened steel throughout. He increased gear tooth width from 12 mm to 25 mm. He designed oil bath lubrication to prevent dirt intrusion. Most critically, he created a dual epicyclic system, one gearbox for speed, another for steering. A driver could change gears with one hand while steering with the other, 2 small levers replacing the chaos of the Mark I's crew coordination nightmare. When Wilson presented his drawings to the War Office in early 1917, the response was predictable: rejection. A colonel from the Tank Corps, name lost to history, competence equally absent, declared the design too complex for the mud of France. The thinking was agricultural: simpler is always better. If farm boys could barely maintain a tractor, how would they handle planetary gears? Wilson didn't argue. He built a prototype. He used his own money and Foster & Co.'s machine shop, working through nights while official tank production continued with the flawed Mark I design. By August 1917, he had a functional test rig, a complete epicyclic transmission mounted on a bench connected to a small engine. He invited the skeptics to Lincoln. The demonstration lasted 4 minutes. Wilson, 43 years old, balding, wearing oil-stained coveralls, sat at the controls. With his left hand, he moved a single lever through 4 gear positions, forward and reverse. With his right, he operated the steering lever. The transmission shifted smoothly, quietly, no grinding, no crew shouting coordinates. One man, full control. The senior officer present, Colonel Philip Johnson, who would later command the Tank Corps' central workshops, said nothing for 10 seconds. Then, "How soon can you build 500? And this is where the story takes a turn no one expected. But before we get to that, if you're finding this untold history as fascinating as I am, drop a comment below. What WW1 innovation do you think changed the war most? And hit that like button. It tells YouTube to recommend this to more history lovers like you. Production began in October 1917. The first Wilson epicyclic gearbox was installed in a new tank design, the Mark IV. Same armor, same tracks, but a mechanical heart transplant. The crew dropped from 8 men to 4. The driver sat in front with 2 levers and foot pedals. Behind him, a commander and 2 gunners. No gearsman wrestling brake levers. The tank could now pivot turn, locking one track while the other drove forward, executing a turn radius the Mark I couldn't dream of. Field trials at Bovington Tank School showed a 60% reduction in crew fatigue and a 40% increase in operational range, simply because the driver wasn't exhausted after 30 minutes. But Wilson wasn't finished. He saw the epicyclic gearbox as a platform, not a final product. Through 1918, he refined it obsessively. The Mark V tank, introduced in May 1918, featured his fully mature design, a 4-speed epicyclic gearbox with synchronized steering. The driver operated 2 vertical levers, left for gears, right for steering, and could execute turns, gear changes, and speed adjustments without ever removing his hands from the controls. For the first time, a tank could reverse out of trouble under full control.
At the Battle of Amiens in August 1918, 414 Mark V tanks smashed through German lines, moving at speeds up to 4.6 miles per hour, executing coordinated maneuvers that would have been impossible 2 years earlier. German soldiers reported shock not just at the armor, but at the maneuverability. These weren't blind beasts anymore, they moved with intention. Here's what most histories won't tell you. Wilson's gearbox didn't just improve tanks, it redefined what a tank could be. Before epicyclic steering, tanks were essentially self-propelled bunkers, useful for breaking wire, terrifying to behold, but tactically limited. After Wilson, tanks became cavalry, mobile, responsive, capable of exploitation and pursuit. The German A7V tank, introduced in 1918 as a counter to British armor, used a traditional sliding gear transmission. It required a crew of 18 men, 6 of whom did nothing but operate the drive system. It was slower than the Mark V, harder to steer, and prone to breakdowns. Only 20 were ever built. Germany lost the tank war not because of armor or guns, but because they never solved the control problem Wilson had cracked. Now here's something most documentaries won't tell you. Wilson received almost no public recognition during the war. William Tritton, his partner, was knighted in 1918. Winston Churchill took credit for championing the tank program. King George V visited tank factories and praised the workers. Walter Wilson remained a serving Royal Navy commander, working in obscurity at the Tank Design Department in Lincoln. His name appeared on patents, patent GB 110988 for improvements in gearing for vehicles, filed January 1918, but never in newspapers. If you want to go deeper into the engineering secrets behind these weapons, make sure you're subscribed with notifications on. We're covering the stories that textbooks skipped. The interwar years should have been Wilson's vindication. Instead, they were stagnation. The British Army, traumatized by WW1's carnage and broke from its cost, lost interest in tank development. Production stopped. Design teams disbanded. Wilson returned to civilian engineering, consulting on automotive transmissions and marine engines. But his gearbox had gone into the world. In 1928, Vickers Armstrong developed the medium tank Mark II using an epicyclic transmission directly derived from Wilson's patents. In 1934, the Soviet Union's T-26 light tank, produced in quantities exceeding 10,000, used a gearbox system that Soviet engineers had reverse-engineered from captured British tanks. The design spread like wildfire because it worked. Every nation developing armor faced the same problem Britain had in 1916. How do you steer a multi-ton machine with human operators? Wilson's answer became universal. By 1939, as war returned to Europe, nearly every tank in service, British, German, Soviet, American, used some variation of epicyclic steering. The German Panzer III, backbone of the Wehrmacht's armored divisions, employed a Maybach Varirex transmission, 10 forward gears, epicyclic final drives, single-lever steering. The Soviet T-34, arguably the most influential tank of World War II, used a 5-speed gearbox with epicyclic steering clutches. American designers at Rock Island Arsenal studied Wilson's patents extensively when developing the M4 Sherman. The Sherman's transmission, built by Chrysler and Ford, was a direct descendant. Controlled differential steering, epicyclic reduction gears, one driver. Think about what this meant on the battlefield. June 1944. An American Sherman tank driver, 19 years old, trained for 6 months, could navigate bocage hedgerows, execute pivot turns in village streets, and reverse under fire with competence.
His grandfather's generation in 1916 had required 4 men and perfect coordination just to turn left. That evolutionary leap wasn't bigger engines or thicker armor. It was Wilson's gearbox, refined and mass-produced, teaching an entire generation of tank crews that steering could be intuitive. The German Tiger I, introduced in 1942, weighed 56 tons, double the Mark V, but its Maybach-Ulvar transmission allowed the driver to execute turns using the same principles Wilson had established 25 years earlier. Epicyclic gearing scaled infinitely. It's impossible to hear these stories without feeling something: anger, awe, sadness, all of it. Here was an innovation that changed armored warfare forever, that became standard in every military on Earth, and the man who created it was never celebrated. Let me know in the comments how you're processing this, and if you believe these forgotten engineers deserve to be remembered, that like button is how we make sure their stories don't disappear. Walter Wilson died on February 29, 1957, at age 83, in his home in Staines, Middlesex. He'd lived to see his gearbox in Korean War Centurion tanks, in Soviet IS-3 heavy tanks rolling through Red Square, in American M48 Patterns. He never gave interviews, he never wrote a memoir. The obituaries mentioned his naval service and his work on early tanks, but spent more words on his later automotive consulting. The Times of London gave him 4 paragraphs. The Royal Automobile Club noted his passing in a membership newsletter. No state funeral, no military honours. His patents, dozens of them, covering steering mechanisms, gear systems and power transmission, generated millions in licensing fees for the British government and private manufacturers. Wilson himself received his naval pension and modest consulting income. The injustice isn't just personal, it's cultural. We remember generals who ordered tank attacks. We build memorials to infantry who died in them. We know the names of Churchill, Patton, Rommel, men who used tanks to execute strategy. But the engineer who made tanks usable, who solved the mechanical problem that made armored warfare possible, we forgot him. Not because his contribution was small, because engineering to the public imagination is invisible. The steering lever is taken for granted. The fact that one man can control 40 tons of steel is assumed. We see the tank, we don't see the gears. But here's the legacy that outlived Wilson's anonymity. Open the maintenance manual for a modern M1 Abrams tank. Flip to the section on the transmission. You'll find a diagram of the X1100 3B transmission, a hydrokinetic automatic with epicyclic gear reduction and controlled differential steering. The terminology has changed. The materials are modern alloys. The control system is computerized. But the fundamental architecture, sun gears, planet gears, ring gears, brakes and clutches working in concert to convert engine power into steerable motion, it's Wilson's design, 105 years after he sketched it on drafting paper in a Lincoln factory. Every tank rolling today, American, Russian, Chinese, Israeli, Korean, uses epicyclic final drives. The Merkava, the Leopard 2, the T-90, the Type 99. Different nations, different doctrines, different politics. One gearbox philosophy. When the US Army developed the Future Combat Systems program in the 2000s, proposing next-generation hybrid electric tanks, the transmission designs still incorporated epicyclic reduction gears. When defense contractors imagine autonomous armored vehicles, the steering models simulate epicyclic clutch actuation. The idea is immortal because it solved a problem that doesn't change. How do you turn something that weighs as much as a house? This is just one inventor's story. There are dozens more. Engineers who built the Rolls-Royce Merlin engine, the Norden bombsight, the cavity magneton. Names history forgot. Machines that shaped the world. I've got their stories ready for you. The next video covers the engineer who made radar small enough to fit in a fighter plane. And trust me, that one will change how you see the Battle of Britain. Click that subscribe button, hit the notification bell, and I'll see you in the next one. The engineer the War Office dismissed, the gearbox that won 2 world wars, the legacy that every tank still carries.